Okay, so I'm recording. Like I said, welcome to class this afternoon, and this is chapter or unit 1, and it's on atomic structure. This chapter or this unit is, I guess, like an introductory chemistry chapter. So we'll learn about measurement, which we'll talk about today, things like significant figures, which you might have done in high school. If you've never heard of any of this stuff, it doesn't matter because I'm going to teach it anyways. And you'll be doing this for any of you guys that are in physics. You'll look at this in physics as well. The only difference with chemistry and physics are the types of measurement in chemistry are usually a little different than the types of measurement in physics. Like, for example, we'll look at the mole and we'll look at things like liters and concentration, whereas physics would be more distance and speed and time, things like that. So we're going to cover today probably up to this point here. I'm going to look at the Canadian system of measurement, which obviously doesn't need to be Canadian there. It's basically worldwide. It's the System International, or SI, units of measurement. So these are units that they use everywhere in the world in education, in science, except for the United States and I think 2 other countries. They use imperial units, I think. So they'll use like miles and pounds instead of meters and kilograms. But I mentioned to my class earlier, when you get into high level science, even in America and the United States, so if you went to like MIT or you worked at NASA, they would use the same system of measurements. So the outcome says Canadian, but it's Qatari, it's Japanese, it's the whole world. And we'll end off with accuracy and precision. One thing I'll mention to you guys before I get started is your first quiz online will be about significant figures. And I had some students in the other class asking about, okay, so when is that? And I would say, don't worry about it yet. We'll probably have the quiz online at the end of the week, and you can take a week to do it. So there's no rush for this quiz. It is not online yet. We have to finish this topic first. And when we finish this topic, I'll open up the quiz for you guys, and it will be extremely short, just a little, I guess, practice for you guys to try significant figures. But I'd like you to put that in the back of your minds for now. We're not there yet. We still have to start with our first topic, which is measurement. So this is a little, maybe not the most entertaining introduction to chemistry, but it's very, very important. I just had a question in the chat about the quizzes. Are they multiple choice? And the answer is yes. There's multiple choice and maybe a few fill in the blanks, but nothing crazy. The quizzes are only worth about 1% each, so they're very short and quick. It's mostly just to make sure you guys are kind of understanding the material. All right, so back to this measurement. Measurement is the easy definition. It's the assignment of numbers to an object or event, right? So let me think about your everyday life. What type of measurements would you see? Well, if you like to cook or bake, you would measure food all the time. You would measure, a cup of flour, 50 grams of butter. These are measurements you would use all the time. Maybe you go to the doctor and the doctor weighs you. That's a measurement. Maybe a more common one, if you're not a baker or you don't weigh yourself all the time, is when you drive or you get an Uber or a Careem or whatever. Distance is a measurement. So if it says you're 10 kilometers away from, Festival City Mall, that's a measurement. And the speed limit on the road, whether 80 kilometers an hour, 100 kilometers an hour, they are all measurements. So any measurement needs to be or is judged by three criteria or three values. It's the level of measurement, so like the size of the measurement, the dimensions or units of that measurement, and the uncertainty in that measurement. And I'm going to go through all three of these. Okay, so we'll talk about magnitude or level of measurement. Whenever you see the word magnitude, just think of the word size. Oops, sorry guys. Okay, so size of the measurement and dimensions. What units will you use? Will you use grams, kilograms, liters? And then uncertainty. And uncertainty is kind of like error. Or even you could say confidence. How confident, how happy are you with the measurement? Do you think it's good? Is it accurate? Is it real? Or did your measurement device have problems? Before I get into what magnitude and units are, I had a question in the chat about the quiz. There will be a quiz next week, an online quiz. Only, they're only worth 1%. Actually, I think they're around maybe 1.1%, and that will be next week. Okay, not this week. So back to this. To describe anything in nature, since the beginning of early science, I don't want to put a date on it, but humans have been making measurements since we've even thought about understanding nature. You might not have measured things in meters 1,000 years ago, but they might have used, like, for example, feet. You could use your own feet to measure something. Walk, how many steps does it take to go this distance? Measurements have been taken for thousands of years. And I'm doing air quotes here. I know you can't see me, but in modern times, we've kind of honed in, redefined these measurements so that everywhere in the world we use the same values. A good measurement is expressed in terms of size or magnitude and units. When you measure something, you can't just say a number. So if I asked you how, and let's just picture we're on a class field trip and we go to the United States. Okay, so we're in the United States and we're staying at a hotel and we're gonna go to a museum. And I ask you guys, hey, can somebody look up how far the hotel is from the museum? And you said 10. Well, that is a meaningless measurement. You gave me the magnitude. You told me 10, but 10 what? It could be kilometers. It could be miles, because we're in the United States and they use miles there. It could be yards. I mean, there's tons of units of distance. Nautical miles. I mean, there's so many different units. So anytime in physics or chemistry, and this is a big thing that I see on tests all the time, when we ask you a question, you can't just say a number. I need you to give me the size of the number and then tell me what units it is. Is it grams? Is it liters? Is it kilometers? We need to know. So the very easy example that I stole from a physics book years ago is just this pencil here. And you could say that the pencil is 7.5. That would be your magnitude or your size. But 7.5 what? Now it's a pencil, so obviously it's probably centimeters, and sure enough, this ruler measures in centimeters. So 7.5 centimeters is our measurement. All right, that's it. I mean, I know this sounds weird and this is very common sense, but you'll see why this is important in a little bit. When we talk about significant figures, this will kind of all link back together. So what I find interesting is, or what I love, I guess, about science is these units of measurement, and this is a very wordy definition. So I'll try to explain it in simple words after I read it. A unit of measurement is a definite size or magnitude of a physical quantity. So it's not like, it would have to be like a real quantity, something we can measure, defined and adopted by convention or scientific law that is used as a standard of measurement for that same physical quantity. Okay, that's confusing. Big, complicated definition. In simple words, a unit of measurement is a definite number or quantity that doesn't change. And it's been adopted or used by convention, meaning like the world, and it's used as a standard all over. So if I measured a kilometer in France, it would be the exact same as a kilometer in South America. It would be the exact same as a kilometer on the moon. It's a universal measurement accepted by a community. And in this case, the convention or law is the scientific community. Any other value of that physical quantity is a multiple of that unit. So, let me get to the next slide and I'll explain that part. And again, I always found this interesting. All of these numbers we use, they're all made up, okay? They're all just numbers that someone somewhere in the world said, this is a meter, and everything is based on this object that's a meter. And if you measure something that's 10 meters, that means it's 10 times longer than the meter. So length is a physical quantity. The meter is a unit of length, and it's a predetermined length. This meter is the same everywhere in the world. So 1,200 meters is 1,200 times the meter. Historically, so from 1889 to 1960, the meter was literally a metal bar that they had in France. I'm pretty sure, I haven't looked this up in a while, but I'm pretty sure that this you can find in France. And that's all it was. It's just a made up number. So someone somewhere in the world just said, okay, this bar, and in this case, it was an alloy, a mixture of platinum and iridium. And it was cut to this length, and they said, that's a meter. And the whole world, eventually just agreed and said, okay, this is a meter. Very interesting. You don't really need to know this for any quizzes or anything like that. I'm not going to ask you the history, but it's good to know where these numbers come from. And if you're bored tonight or tomorrow, you can Google this stuff and see where the numbers come from. Like, why is a second a second? Why is a kilogram a kilogram? And there's answers to this. So these units are called SI units. SI, International System of Units. And the reason it's written SI, I think, is because it's French, System International. I used to know French a lot better, but not anymore. It's used in Canada and most of the world. So obviously Qatar, and again, even in the United States, in the scientific community, they would use these units. Okay, so the next slide is the first important slide. What are the SI units? There are 7 of them, okay? And the 7 units, these are used to define all other units in science. It's actually quite amazing. This says, the interdependency of their definitions. Most of them are related in some way, but we don't need to worry about that. So let's start at the top with maybe the most interesting one. Kelvin, K. This measures temperature. And any of you who haven't done a whole lot of science, or maybe don't remember a lot of your science, you might be thinking, well, what about Celsius, or even Fahrenheit? Well, let's leave Fahrenheit out of this. That's useless. Celsius and Kelvin are very closely related. Kelvin is the scientific unit of temperature. And I won't go into much detail of why. We are going to cover Kelvin in Unit 6. I will tell you that if you wanted to convert degrees Celsius to Kelvin, all you do is add 273.15. Okay, so for example, it was almost 40 degrees today. I think it's 38 right now, but it was almost 40 degrees. So if it was 40 degrees Celsius, you could change that to Kelvin, and it would be what? 313.15 Kelvin. The short answer to why this is used, and guys, you do not need to know this for now. This is nothing you need to know for now. Do not worry. This is for later. But the simple reason for why they can use Kelvin is there's no negative values. Not typically anyways, under normal circumstances. So the coldest we would get, they would call it absolute zero, and it would be 0 Kelvin. And I don't know if you've traveled to anywhere really cold, but you guys know, or I hope you know, that Celsius in many countries where there's snow will be negative. So like where I'm from, it can be -20, -10 degrees Celsius. With Kelvin, we don't have to worry about negatives. Anyways, you guys, we'll do more of this in Unit 6, so don't worry about that for now. All you need to know is that the SI unit for temperature is Kelvin, and temperature is a very important unit for chemistry. So this is one of the few that we need to know for chemistry. All right, the next unit, the second. The second measures time. You've heard of this before. Definitely a useful unit, but you guys won't need this until the next chemistry course. So this is not one we'll use in chemistry 1120. The next unit is for length. It's the meter. This one we will use in chemistry, but we'll use it a little differently. In chemistry, we will use volume, which is meters cubed. Okay, we use volume in chemistry all the time. Liters, milliliters, right? So liters or milliliters. Milliliters would be centimeters cubed. That's something we use all the time. Kilogram, this is a big one in chemistry. In chemistry, we typically use the gram, which is just a factor of the kilogram. It's 1,000. Well, you multiply by 1,000 to get grams. So that's a big one in chemistry. This next one, I've never used in my life. I don't even know if I heard of it in university. I have a feeling it would be very useful in physics, and I did mostly chemistry in university. But the candela, again, one I've never heard of until, after university, is measures brightness or luminous intensity. That is definitely not one we'll use. The mole, this is the big one. Okay, this is the #1 unit in chemistry. This measures the amount. I will talk more about this in Unit 3. Okay, so we'll come back to that in Unit 3. I could talk about that unit for 2-3 classes. So I'm not going to get into that today, but it measures the amount of something. You can think of it like the word a dozen meaning 12. Well, a mole is the science version of a dozen. And the last one, which again you won't use in 1120, is the ampere. You will use ampere and seconds in 1121, the next chemistry course, in your electrochemistry unit. The ampere measures electric current. Okay, so there's your 7 base units, and let me just show you. So again, we would need to know mass, length, but by length I mean volume. You would want to know Temperature, we'll do that in unit 7 or unit 6. And the mole, that's unit 3. Mass we'll get into in unit 3 as well. I think volume would be unit 4. I think 4. It'll be 4 or 5, but I think it's 4. All right, so there you go. Time, electric current, and luminous intensity. So seconds, amps, and candela, don't worry about for now. Again, I've never heard about candela until after. I just had a question about chemistry 2. Yeah, that will be next semester. So you guys, assuming you, mechanical students, if any, I have almost 30 people here. Mechanical, I don't think you do chemistry 2. But a lot of other people, especially the chemical engineering definitely does chemistry 2. Mechanical, no chemistry 2. You're lucky. Well, I don't know. I shouldn't say lucky. Chemistry 2 is my favorite course in the whole college, but anyways. All right, I'm almost done, guys. I don't want to go too long on my online classes, like I mentioned, just for, attention span. And this is hard to listen to for more than 20, 30 minutes. So I'm almost done. I think I have 4 more slides and we're done. Okay, so there's not much to say here on this slide, number 11, except that those 7 units obviously don't cover all units. Think about measurements in your real life that aren't included. So things like kilometers per hour, that would be your speed or velocity. That's what we would call a derived unit. It comes from taking the length and dividing it by time. Another big one in chemistry, like I mentioned earlier, is the volume. The volume is the length cubed. So length times width times height for a cube, or is different for other objects, but this would be like milliliters, liters. This is volume. Okay, that's a big one. You, again, for quiz purposes, you don't need to know where units come from, but you should know what the units stand for. So if I asked you, for example, what does Kelvin measure? You should know that it's temperature. If I ask you what the meter measures, you should know that it's length. All right, 3 more slides and we're done. And no problem if you're disconnecting. I don't notice it at all. So just try your best to keep online. Not much you can do, I guess, but if any of you guys are having connectivity problems, these will be up on YouTube soon. I'm just setting up my YouTube channel now. So by the end of the week, all these videos will be up on YouTube for you. All right, 3 more slides. And this is, I'm going to end the class today with a really important topic, that you will definitely be expected to know on your first quiz, well, test, not quiz, but the one that you write on campus in week 7 or 8. So in a couple weeks, well, in 7 weeks, a long time away. There's something I'm going to show you in a minute that's very important. So first, all of these measurements I've been talking about are subject to uncertainty. And when in English, when you say you're uncertain, it means you're not sure, like you're not confident. So if somebody asked you, a classic example, a police officer pulls you over, and the classic question you see in the movies all the time, sir or ma'am, do you know how fast you are going? And if you weren't watching, then you might be uncertain. So you might say, oh, I was, officer, I was only going 100 kilometers an hour. And then the officer might say, well, you were measured going 115. So you were not very certain in your answer. In science terms, Every measurement we make, whether it's using like a ruler, using a piece of glassware, like in the lab, we use a lot of beakers and pipettes and burettes. They all have an uncertainty to them. They're not perfect. Okay. And that's probably an easy way to explain uncertainty. It's not perfect. So a piece of equipment that we'll look at next class, I'll talk about the pipette next class, but all you need to know is it's a piece of glassware that measures incremental volumes. What I mean is you could take a pipette and measure 10 milliliters, or another pipette and measure 25 milliliters. Well, the pipette has an error, a margin of error on it that says 10 milliliters plus or minus 0.1 milliliter. What this means is when you actually measure 10 milliliters, it can have a range of 9.99 milliliters, to 10.01 milliliters. It has this range of confidence. And I won't get into it too much, but I just want you to think it's like tolerance, exactly. And someone in the comment chat just said tolerance. It's, tolerance for error, I guess. I could talk about this all day, but I just want to say you might not think that this is a big deal. And in chemistry 1120, it is not a big deal. But if you were an engineer working for NASA and you wanted to launch a rocket to the moon that had 3 humans on it, well, you want to be confident, right? You don't want to miss the moon or not miscalculate your fuel and not have enough fuel to get home. Or, this concept of uncertainty and margin of error, when you look at engineering where people's lives are in danger, or you look at pharmaceuticals, so you're making medicine for people, you need to be confident and not uncertain in your results. If you gave someone, please stop marking on the screen, thank you. If you gave someone the wrong dose of medicine because you measured it improperly, you could kill them. So this is pretty serious in future science courses. So the last part of today, guys, this will just take me a few minutes and you're free to go, is this concept of accuracy and precision. And guys, this is something you will see on a future test or final exam for sure. So this is something you want to know. Uncertainty in a number depends on the accuracy and precision of your measurement device, your instrument. The accuracy of a measurement is, so I'm defining them right now. The accuracy of a measurement is how close it is to the actual value. And that's a good way to remember it. Accuracy, actual value. And by that, I mean the real value. If you were measuring gravity, we know that we know what the gravity is, okay? And you were measuring gravity and you were getting a number that was very far off the true value, you know that that's not accurate, okay? If you knew that you weighed, let's say 70 kilograms, and you went to the doctor and he weighed you or she weighed you, and the doctor said you weighed 100 kilograms, and you knew that wasn't true, that's not an accurate number. Precision is how repeatable your measurements are. And what I mean by that is if you measured the same object 3, 4, 5 times, if it's precise, the number should be the same each time. So again, you can imagine if you weighed yourself, you step on the scales, and the first time you step on the scale says 50 kilograms. You step on again, and it says 60 kilograms. You step on again, and it says 75 kilograms. That is not precise. So the easiest way to understand this is using this called these diagrams. They call them bullseyes. They use them in darts or archery. The idea is the middle of this graph or chart is the true answer. So if you have something that's accurate and precise, they would all be in the true answer range. You know, if I was measuring, again, like you could say gravity, 9.8, it needs to be 9.8 every time I measure it. Now, this is another problem. Your measurement can be precise, meaning they're all close together, but not accurate. This is a very big problem in experiments, because if you did this in the lab, you might think you had a good answer, but typically what you need to do when you have this situation is you have to calibrate your equipment, meaning you have to fix it and move it towards the true value. So something that is precise but not accurate, you can fix this, and the method of fixing is called calibration. We do it in the lab all the time. So if I was going to rank this from happy to sad, this guy over here, this is your happy place, right? Very happy. This guy here, not so happy. You could fix it, but it's not a good result. And then this guy over here, definitely the most sad. You know, he's crying. This is the worst possible situation you could have. Your results are not precise and not accurate. Okay, you're not in the middle, and your results are everywhere. So guys, it's 3:14, 3:15. I went a little longer than normal. I apologize. I won't normally go this long. I'm going to stop it here today. But before you all log out or say goodbye, just make sure you make a note. Your first test and your final exam, you do have to know the difference between accuracy and precision. And I'm going to stop talking there now. If you guys have any questions, let me know. I'll stop recording as well. And if you have no questions, have a great day, and I'll see you, I guess, tomorrow.